Hello, Honors Algebra 2 students. We are on page 169 of your student journals, and we're going to talk today about graphing exponentials and logs in a little bit more detail. We're going to talk about how we can translate them left and right. We've talked a little bit about this in the past, but we're going to kind of dive into this a little bit. And I actually lied. We're not on page 169. We're on page 171. So I want you to jump ahead to page 171. And this is lesson 6.4. All right, so one of the things I want you to remember is like an exponential and a log function, obviously, as we talked about before, are inverses of each other. So they have opposite kind of operations, right? So an exponential function without any shifts would have an asymptote y equals 0, as opposed to a log function without any shifts would have an asymptote at x equals 0. And just as a refresher, remember those asymptotes are kind of like the line where the graph approaches but never touches or crosses. And so the graph is going to get really close to that value but never actually hit it. All right, so an exponential function, and if you remember just kind of our basic, right, we're going to add in the h and the k. And just remember that the h and the k, and I know we've talked about this a little bit, but the h and the k do the same thing as if it were any other function that we've talked about. So just kind of a refresher, the a value is kind of our starting value. And so a lot of times on the graph, what I do is I kind of use a little x there just to kind of show that that's kind of where my starting value is. And then I start translating it. So I translated it left and right, and I translate it up and down based on what my h and my k are. This b value, remember, is your growth or decay factor. So that's going to tell if your function is increasing or decreasing. Remember, if this is an e, if the base is e, then it depends on if your exponent is negative or positive to determine if it's increasing or decreasing. A log function will be very similar, okay? So you'll have kind of a starting value. In most cases, our starting value is going to be 1, okay? All right, so here's kind of the interesting thing about logs. So whereas our starting value here is kind of on our y-axis, this is our kind of our y-intercept of sorts before we start translating it, the log function, because it's an inverse, is starting on your x-axis before we start translating it. And so then, again, you would translate it left and right. So this would be your translated intercept. So you'd start here, and then you'd move it left and right, up and down, based on your h and your k. This b, this base here, kind of like the base here, the b value determines kind of the steepness of your graph or how quickly it increases or decreases. And so you'll only kind of be able to judge that if you A, either graph it in your graphing calculator and look at it, or B, if we plot multiple points other than just the translated intercept. And so I'm going to show you how to do that today. Just remember kind of the asymptote here. The key thing here is, remember, this represents your asymptote in your exponential function, and this represents your asymptote in your log function. So these are kind of where we get our asymptotes from. And then this is still my starting value, this is still my starting value, and then h and k shift my graph, just like it always has. This chart is kind of helpful if you can understand it a little bit. So again, this is just kind of going back to what we've already talked about in previous units. Like horizontal translation just means left and right. So that would be like f of x minus h. F of x minus h would move your graph to the right, and f of x plus h would move it to the left. So you would see, 4 to the x minus 3 is 3 to the right, 4 to the x plus 2 is 2 to the left. So this is kind of a nice little chart to kind of show you what the transformations are going to look like. Vertical translation, just up and down. So again, like the plus 5 here causes my graph to move up, the minus 1 causes my graph to move down. We can have reflections, and so we can have a reflection over the x-axis or the y-axis. So if you're going to reflect over the y-axis, remember that you're changing just the x. So you're multiplying just the x value. So it would look like that, 4 to the negative x. Let me zoom in a little bit. So 4 to the negative x would be a reflection over the y-axis, whereas negative 4 to the x is a reflection over the x-axis. And so we've talked about this in other functions, but just kind of, this is what it would look like in an exponential. As you can see, all of these examples are exponential. We'll go through another chart with logs. Horizontal stretch and shrink, again, that's kind of what's happening to your x value of your function, so f of a times x. In other words, if you have 4 and it's raised to the, say, the 2x, that's a horizontal shrink by a factor of a half. So remember, with horizontals, that's the only one that we take the reciprocal of, okay? So remember, we have to do that reciprocal. So if it tells you a factor, you have to take the reciprocal of that. So this would be a horizontal shrink by a factor of 1/2 would look like 4 to the 2x. A horizontal stretch by a factor of 2 would look like 4 to the 1/2 x or 4 to the x over 2, either way. And then don't forget about a vertical stretch or shrink. That's just multiplying the entire function by that amount. This one you don't have to worry about taking the reciprocal. So if it's a stretch by 3, you're just multiplying the whole function by 3. If it's a shrink by 1/4, you're multiplying the whole function by 1/4. Also keep in mind that you are applying that to the whole function. So if you're doing this vertical stretch or shrink after you have a function that's already been shifted up or down, you would multiply that k value, right, by that vertical stretch or shrink. All right, so those are all exponentials. Let's look at the log one. So go to page 172. So this is just kind of the same chart, but just with log functions. And they have similar. So left and right, you will notice x minus h, x minus 4 moves to the right, x plus 7 moves to the left. F of x plus k up and down, same kind of operation. Here's a reflection over the y-axis, the negative, you would take the log of negative x, whereas opposed to negative log of x is a reflection over the x-axis, and we'll talk a little bit about that today. Horizontal stretch and shrink, again, this is the reciprocal. So you may want to take a note of that. So a shrink by 1/4 would mean that you do 4x inside your log. You're taking the log of 4x. A stretch by 3 would be 1/3 x. And then, of course, the vertical stretch and shrink, again, is multiplying the entire function by that value. All right, let's just kind of get a little bit of practice with some of this. So if I give you a function, so we'll just, okay, so let's say I give you the function f of x equals e to the x plus 2 minus 1. And if we could list our transformations. So what I want to remind you is that an e just means that it's still an exponential function. It's raised to a power. But I want to remind you that it is just has a basic e. That's the only difference. So this plus 2 causes my graph. It's a horizontal translation. So that means it moves it left and right, and this would be left 2. So that's what that does. And then this would be a vertical translation. Remember, translation just means to kind of slide it. And this would be down 1. Let's do one more example. How about if I give you g of x equals 2 to the 2x minus 4. So I gave you this one on purpose because this is kind of where a lot of people mess up when it comes to like determining what your horizontal stretch or shrink is. Because this 2x minus 4, it's not in the proper format. So what I mean by that is, in order to figure out, so if you look back up here, if you if you look over here, your vertical stretch or shrink, notice that they're applying it to just the x. Well, if you have a number after this, like you moved it left or right, you have to factor that out. So what I mean by that is it needs to look like this. So the vertical stretch, or in this case, I'm sorry, the horizontal stretch or shrink has to be the factor, the number, the multiplier of the entire exponent. So like, for example, I'm multiplying the exponent x minus 2 by the factor of 2. So what this does, okay, so this 2 is a horizontal shrink by 1/2. And then it's also so the minus 2 here causes my graph to go, so I guess it would be a horizontal translation. So that just means right and left of right 2. So if you're looking at it like this, this is kind of how I would describe the transformations. Now you might get a couple different variances on this. But again, this is kind of where I'm thinking like the basis for what I'm looking for. Let's do one more, but this time I'm going to give you something a little bit different. This time I'm going to say, okay, so in option C here, I'm going to give you the function f of x equals 3 to the x. And I want you to do the following things. I want you to reflect it in the x-axis. I want you to go a horizontal translation of 2 units. Let's go left. And do I want to do anything else? No, let's just start there. All right, so reflection on the x-axis and 2 units to the left. So remember, a reflection in the x-axis would be, if you remember, going back to your chart here, a reflection in the x-axis, you multiply the entire function by that -1. So what it would look like is like -1 times f of x. So in other words, you're going to go -1 times 3 to the x. Or in other words, -3 to the x. Now be careful here that the negative is not being raised to the power, right? So the negative is not being raised to the x. So a lot of times I'll write it like this just to kind of show that the negative is not being raised to the x, because we have to follow order of operations. All right, next, 2 units to the left means that I'm going to go x plus 2. So I'm replacing x with x plus 2. So I'm going to go -3 to the x plus 2. Like that. You could do this with a log function as well. I'm going to run out of room here, but we'll try to squeeze it in here at the end. So let's say I gave you a log function. So log base 1/6 of x. We'll say that's f of x. All right, let's do transformations of 1 unit down and a vertical stretch of 5. Okay, so let's see what this would look like. 1 unit down and a vertical stretch of 5. So again, you would shift this the same way you would with an exponential. 1 unit down would just mean that you're subtracting 1 from your log function. So this would be log with a base of 1/6 x minus 1. So the entire function's being subtracted by 1. A vertical stretch by a factor of 5 means you're multiplying the entire function by 5. So you would get 5 times log. So this is what I was kind of telling you about in order to make sure that you remember to multiply the entire function by it. So a lot of times the mistake I see is that you just put the 5 in front of the log and you forget about the -1. So what this would look like is 5 log base 1/6 of x minus 5, because you have to distribute that 5. All right, and so now that we've talked about some transformations and kind of what they are and kind of done that part of it, let's talk a lot more about graphing. So on this page, it's your extra practice. I'm not going to do all of these, but we're going to chat about a few of these, and then I'll let you guys kind of try some of these on your own. You can do these on a separate sheet of graph paper if you feel like this grid is not enough, or if you'd like a little bit more room. So feel free to grab some of your own graph paper if you would like. All right, so we're going to graph a few of these, so the first part of this says describe the transformations of f represented by g. Okay, let's start with number 1. Let's just look at the transformations. So all I'm really asking you to do here is say, okay, from 6 to the x to the 6 to the x plus 6, what did we do? Well, that was a vertical translation of up 6. So that's all I'm really asking you to do here, is to describe the transformation. I'm not going to graph all of these, but let's graph number 3, because this is a log function. I want to show you how to do this one. So let's first talk about the transformations. So we go from log base 5 of x to half log base 5 of x plus 7. So the first thing you might notice is this 1/2 out in front. It's going to be your 1/2 is a vertical stretch. And then the plus 7 means I'm going to go left 7. Right? So this is the vertical stretch. I'm sorry. Yeah. And then this is going to be your right or left. So in this case, it's left. All right. So I'm going to go ahead and draw in my grid. And I already know kind of what this graph is going to look like. So I'm going to draw my axes just because I'm going to use this grid paper. And again, if you want to use your own grid paper, that's fine. I'm going to draw it so it's like this because my graph is going to be pushed to this side. And now I am going to graph this. So the first thing I want to do when I graph this is, so some people like to start with the asymptote or start with the, that starting value. I like to start with the starting value, which in this case is a half, which this is a really weird because you're going to have to kind of estimate here a little bit. So I'm going to put my x at positive a half and then apply my transformation. So my transformations mean to go left 7. So if I go left 7, that's 1, 2, 3, 4, 5, 6, 7. So I end up right here. So I'm going to put a dot here actually. That's going to be what we call our translated intercept. So that's going to be at the point negative 6.5, comma 0, right? So that's that point right there. All right, let's do our asymptote next. So remember with the log function, it's your whatever's happening to x. So in this case, it's at left 7. So it's going to be at negative 7. Please label it. So x equals negative 7. And then what you're going to want to do is grab a couple other points. Okay, so we've gotten the point of negative 6.5. and then comma 0. We've got that one, right? So if we graph, we're going to graph the translated one. So if we graph, let's say, another one, let's say we do, I don't know, it doesn't really matter, but let's graph, let's just graph when x is, well, let's graph when x is like negative, so this is negative 6.5. Let's graph when x is negative 5. Let's just kind of get a feel for what that would be. So if I plug in negative 5 here, negative 5 plus 7 is 2. Log base 5 of 2. So let's go into our calculators, hit math, arrow up. Log base 5 of 2 is about 0.43. And then remember we have to multiply it by a half because there was that vertical stretch. So I get about 0.2, whoops. So what that means is that this is going to be a really, so at negative 5, 1, 2, 3, 4, 5, I'm like right here. It's going to be kind of a shallow one. Let's one that's a little bit easier for us to do. Let's do like negative 2. So negative 2 would give me log base 5 of 5. Do you know what log base 5 of 5 is? So if you don't, remember, think about how we evaluate this. Like if we set this equal to x, and we change this into exponent form. So 5 to the x equals 5. What number does x have to equal here? Well, it has to equal 1. So log base 5 of 5 is always 1. So 1 times a half is a half. So at negative 2, we're at a half. So what this tells me is that my graph, so you should already kind of know the shape, but this gives me the kind of the steepness of our graph. So it's a really shallow graph is what I'm trying to get at here. All right, let's graph a couple others. Let's do number 4. So number 4, let's look at our translation. So this is a negative, the only difference here is that minus 4/3. And so what we're getting at here is this is going to be down 4/3. So it's going to be kind of a weird one to graph as well. Notice that the base here is 1/3. When that happens, that's going to be a reflection in your x-axis. So anytime you have a value like 1/2 or 1/3, anything that's less than 1 but greater than 0. So when b is less than 1 but greater than 0, that's going to be that reflection in the x-axis. All right, so let's graph this one. I don't think we have to worry too much about what this looks like. Okay, I'm going to start by graphing my starting value, which is here at 1, 0, and then I'm going to shift it down 1 1/3. So it's about right there. Again, obviously we're estimating. The next thing I'm going to do is throw in my asymptote, and since what's happening to x, so remember there's no parentheses around this. If this was written as log with 1/3 x minus 4/3, then this would mean that we're moving it to the right 4/3. Because there's no parentheses, what this means is this is your k value, right? So your asymptote here is still going to remain at 0. Because there is nothing happening to your x, like there's no left and right shift. So this is x equals 0. what I want to show you about what a reflection in the x-axis does. So instead of your graph kind of doing this route, right, kind of approaching it's going from the other direction. It's going to look like this. Now, I didn't graph a whole lot of points here, obviously, so it would be helpful if I graphed a few others to get the trajectory, but that's kind of what your graph is going to look like. And so then you can grab, you can throw in, so if you know that this is the point when x is 1, and you get the point negative 1 1/3, right? So maybe you want to graph when x is, 3. So log base 1/3 of 3. And you can throw it in your calculator, but you should also be able to do that one by hand, but math, go up. So log base 1/3 of 3. So basically what you're saying is, I'm just going to write it on a separate sheet of paper here just so that I can show you. Log base 1/3 of 3. It's like you're asking, okay, well, let's set it equal to x. Let's change it into exponent form. What do I do to get from 1/3 to 3? Well, again, fraction to a whole number, I have to have a negative exponent. And from 3 to 3, it's -1. So I should get -1 as my answer. If I look at my calculator, I do. So again, I was just trying to show you how you can do this in your head. So anyway, this is -1, and then minus 1/3 would be negative 2 1/3, or I'm sorry, 2 1/3. So just to kind of get another point here, 1 2 3 1 2. Yeah, I actually did a fairly good job on that one. So that's how you would generate some points. All right, so here's a couple, like I said, there's quite a few of these here. What I'd like to show you then is maybe a couple others, or maybe at least one more. I know the video is getting a little bit long, so we don't want to do too much. But let me go ahead and graph one more. Let's do an exponential function maybe, and since we haven't really graphed one of those yet. So this is an exponential. A couple things I would notice here. The negative up here is a reflection over the y-axis, okay? The 3 is a horizontal shrink by a factor of 1/3. The +4 means we're going up 4. So there's 3 things happening in this function. There's 3 transformations. And it's also decay. So the first thing I would do, we're going to graph it like this. All right, so the first thing I would do is start with my a value, which in this case is 0, 1, because there's no number out in front. And then I'm going to shift this function up 4. So 1, 2, 3, 4. It's only kind of the only major transformation. 1, 2, 3, 1, 2, 3, 4, right here. All right, it's going to be kind of important that you graph some points in this one. Let's go ahead and graph in our asymptote. So remember, your k value is your asymptote for exponentials. So 1, 2, 3, 4. So your asymptote is actually way up here. And so remember, if this were a decay function, let me just kind of show you what it might look like if you had a decay function. It would kind of look like, like this, right? That would be like your decay, but we're going to reflect it over the y-axis. So what do you think that's going to do to my function if we reflect it over the y-axis? So it's going to make it look like a growth, right? So this negative out here actually kind of changes, just like it would if it was a base of e. It kind of changes whether it's growth or decay. So if this is a decay raised to a negative, it's actually going to look like a growth. So let's go ahead and grab some points off of our table, right? So if I graph that when x was 0, I got 1, 2, 3, 4, 5. So let's graph when x is -1. So when x is -1, I get 1/5 to the positive 1/3, or positive third. So 1/5 raised to the third, and then I'm going to add 4. I get like 4.008. So obviously really close to 4. So -1 and 1, 2, 3, 4. I get something like this. So remember, because this is kind of what the original one would look like without that reflection over the axis, now what I'm anticipating is my graph to kind of do something like this. And the reason why is because it's reflected over that y-axis. So maybe let's plot a point from over here. Let's plot when x is 2. So we can kind of see how far up it goes. So 1/5 to the -6th power. So I'm going to do that in my calculator. I get 15,625. Okay, well that's a lot. When x is 2, okay. And then I'm going to add 4 to it, so I'm going to get a really steep graph is what this is telling me. And so obviously I'm not going to be able to graph this really well because this is going to go really quickly and it's going to move up really quickly. But this is going to be the overall shape. So I'm just going to kind of not even put that point in there just because it's going to probably confuse us more than anything. But again, this original one without the reflection would have been a decay like that. And then because of this negative up here, it's reflecting over the y-axis. It's going to be back to a growth. All right, so you're going to want to practice some of these, and we're going to do a lot more in class. But I would encourage you to practice maybe the other ones that are on this page. Obviously, do the ones. You can also practice some additional ones that are in big ideas. But you're going to want to practice a bunch of exponentials and log functions just so that you can get really comfortable with them. All right, thanks for joining me. That's it for now. Bring any questions you have to class. Bye.